Good. Okay, does that work? You can all see it. Wonderful. Okay, so can I do, yeah, no, not really. Okay, I'm going to do that. Okay, so, oh, okay. And now I realize that my opening slides still have my comments myself on it. Should have corrected that one. Good. You, Steve, you have a record of my incompetence. Good. So, so now we're going to look at the sort of objective, subjective demarcation a little more carefully. I'm glad that Abdul raised these questions. Okay, so for objective statements, there has been a communal, public, critical process leading to a collective agreement on the statement. And subjective statements have not had this critical process, either for whatever reason, either because just practically it hasn't happened, or because for whatever reason it can't happen. So I'm going to take, because of course I like shying away from controversy here, we're going to talk about climate change. Because that's, you know, no one's going to disagree with me on climate change, right? Let's take a statement like anthropogenic climate change is happening. And we're going to ask the question, is this statement objective? And given that we've realized that there are levels of objectivity, we can say, how objective is this statement? And if it's not utterly objective, why is it not utterly objective? And can we make it more utterly objective? And if we can, but haven't, why not? So here we go. Let's take this. Now, there's a whole pile of data out there, which I do not need to throw at you to attempt to convince you that climate change is really happening. The data exists. This is publicly available. And, you know, I mean, the International Panel, Intergovernmental Panel on Climate Change goes out of its way to make it publicly available. Anyone with an internet connection can get this information for free. That's about as publicly available as you can ask for. Anyone that doesn't have an internet connection just doesn't deserve it. That may not be true. We'll come back to that in a minute. Okay, so we get squiggles and we get graphs, and that graph is publicly available. But is the information, is the meaning of this graph publicly available? Specifically, has there been a communal, public, critical process leading to a collective agreement on the statement about climate change? Now, there is not universal agreement about climate change. 3% of scientists, so the statistic goes, disagree on anthropogenic climate change, and some number of the general population don't agree about climate change. So in the sort of hard has it been shown, we know that it can't absolutely be shown. And in the weakened sense of have we got collective agreement, we don't have universal collective agreement, right? So what's going on with this? Well, let's look at what this graph actually shows us. So the IPCC is very helpful. They put a caption on it and they said that figure 1.4, which is this figure down here, is the estimated change in the observed globally and annually average surface temperature anomaly relative to 1961 to 1919 degrees C since 1950 compared with the average range of projections from your previous IPCC assessments. Now, here's the problem. If you don't understand that statement, if you don't know what that statement means, the IPCC has not successfully conveyed to you the meaning of this graph. So there cannot be a public process of discourse involving people who don't understand, excuse me, this sentence, right? And you say, well, we're going to work on for a bit, and we'll come back to this to see if the rest of the caption helps. Okay, so the values are harmonized to start from the same value in 1990. Now, you might be a little critical on this. You're like, well, what does harmonized mean? I know what harmonized means. Harmonized is scientific jargon for fudged, right? They fudged their data to start from the same value, right? They say, oh, look, they've been changing over time. Of course they've been changing because they've harmonized their data. Now, if you work for the IPCC, you know what harmonized means, but no one's explaining it to everyone else. So how can there be a public discourse on this data if a significant fraction of the population doesn't know what is meant by harmonized, And a significant fraction of those bear in mind that possibly harmonized means fudged. Okay, I mean, let's move on. The observed global annual mean surface air temperature anomaly is shown as squares from the UK Hadley Centre Bright Green reanalyses. Right, what was wrong with the data the first time round that they went back and reanalyzed it? Right, was it the fact that the data, you know, it was not going up like it was supposed to? So they went and they reanalyzed it just to make sure it did what it was supposed to. Right. So, is there a public engagement with this? Now you say, well, okay, I don't know what reanalyzed meant. I mean, I'm a physicist. I don't know what reanalyzed meant. Could I find out what reanalyzed meant? Yes, I could. How would I find out? Well, it's very simple. What I'd do is I'd read the rest of the report. It's only 1,136 pages long. It would take me a week or two. I'm sure I could read through it. And the bits that I didn't understand, it only references a couple of thousand papers. So I could spend 30 years at university learning about atmospheric physics. I could go and check. I really could go and check what this paper says. Except I can't. First of all, I couldn't go and check because I don't have 30 years spare. I have other things to do with the next 30 years of my life other than check what the IPCC report says. Because I also disbelieve these NASA scientists who say the Earth is round, and I want to spend 30 years understanding space physics to work out what shape the Earth is. And I only have one life. I can't check everything. I don't physically have the hours in my life to do it. And worse still, the scientists aren't going to sit on their thumbs waiting for me to check it, because in the next 30 years, if I haven't understood and acted on this report, the scientists tell me, we're going to have blown straight past 2 degrees C, we're going to have hit the tipping points, the apocalypse is going to be upon us, and we're all going to fry. Right? I do not have 30 years to read up and understand this report, and the world doesn't have 30 years for everyone to read up and understand this report. You just have to take it and act on it. So in that sense, we do not have time for the entire general public to work out what this report means. But it gets worse than that. So let's have a look. The scientists themselves don't know what all of this report means, right? The guys who send up the weather balloons, you know, it's a team of however many people. And the guy who makes the weather balloons doesn't check the code of the guy who hung the measurement device off the bottom of the weather balloon. The guy who writes the code says, yeah, this code does whatever. And the guy who makes weather balloons is too busy making weather balloons to check. So he says, are you sure? And the guy who writes the code says, yeah, trust me. Why? You know, if I write some code, I know my code. I know to trust it because I've seen the workings of my code and I know how much I've checked it and I know how much I've gone over it. But someone else doesn't know that because they've not spent the time I have checking it. So they just accept it because I say, trust me. And of course, the different guys working on this, I mean, there are the Pierre Auger collaboration. There are, I looked up, I don't have the number. It's like 900 people from 17 different countries on 4 different continents working on this collaboration, right? So even the guys that wrote this paper, have they each checked what they're all doing? The guys within one university haven't, and you know, the guys in Brazil haven't checked on what the guys in Switzerland are doing. But they write this paper together. Why do they do that? Because the guys from Brazil say, trust us. And the guys from Switzerland say, yeah, all right. And the IPCC hasn't gone back and checked every single paper. Some of it they've taken on trust. And they certainly haven't gone back and dug through and said, okay, when this graph in this paper plotted this result, can I please look at the original balloon that you sent up and the original code it was running? They haven't done that. Why not? Because life is too short. The balloonists said, trust us. And the people who wrote the paper said, trust us. And the IPCC said, trusted them. And then they turn around to you and say, trust us. So this problem of saying, I don't have the time to dig into and fully understand the IPCC report goes all the way through. It's not just my problem, it's the problem the whole way through. So does this seem very objective? I mean, even by this weakened definition of public, critical, reflective engagement, the level of critical engagement within the scientific community comes down at some point, always and necessarily, to one person looking another person in the eye and saying, trust me. This is as close as climate change is getting to objectivity. So, can we ask some of these critical questions? Oh, no, okay, sorry, wrong slide. Okay, so this is the situation that we face. So someone who says, I don't trust you, are they being crazy? Right? Someone who says, you know what, the government isn't always honest with me. The people who tend to screw me over, in my experience, are people in government, people with a degree, people with a sharp suit, people with more money than me, who think they know better than me, who are willing to take away my livelihood and shut down my business because the data tells them that's the right thing to do, who don't think about how I'm being screwed over because the data is the only thing that matters, who don't come and talk to me personally, they just write books and hide behind lecterns. Right? These are the people in life who screw me over. And who is telling them that they need to change their life because the world is getting hotter? Well, it's the government, it's people in sharp suits, it's scientists, it's the elite, it's people who know what they should be doing, it's people who trust the data and are prepared to shut down their business, right? Pulling more science data out of it is not going to convince these people, because it's the very fact that the data is scientific which is problematic. And these people are not crazy, right? If every single person that has ever screwed you over was a highly educated elite person funded by the government, then when a university professor with government funding comes and says we need to close down your coal mine because the world's getting hotter, a crazy person says maybe this time it will be different. Maybe I can trust them this time even though I've been screwed over my entire life. That's the crazy response. A sensible, reasonable, considered person who understands the way the world works says, when 97% of government scientists say the world is getting hotter, I'm with the 3%, right? That person is not crazy. So how then do scientists engage with people who are strongly opposed to the scientific consensus? How do they engage with people who are strongly opposed to the scientific consensus exactly because it's the scientific consensus? Well, let's have a look at how science works. And this is going to get to Abzal's question. Okay, first of all, I convince a colleague, right? If I get some result, I'm like, oh, this is awesome, and I say this is brilliant, and then I collect my Nobel Prize. Well, no, that's not how it works, right? First of all, I convince a colleague. I call someone over. I say, look at this result that I've got, and they look and they go, no, that voltmeter is broken. That always gives that result. So my bias, my own personal inbuilt excitement to overlook the wider considerations, because I say, well, this confirmation bias, this confirmed what I expected, this confirmed my theory, this is a bias, this is a well-known cognitive bias, and I didn't notice it because I was so excited with my theory being confirmed. But my colleague, who doesn't care about whether my theory is confirmed or not, looks and says, I know that voltmeter is broken, use a different one. So I need to convince my colleague, and that makes my view more objective. Once I've convinced him, this is more objective than just me being happy about it. Okay, it's still not utterly objective, but it's more. Then I go and I convince my group. Once a week we have a group meeting and we all sit down and I print out my plots and I say, this is it. And they look at it and they go, well, did you check that voltmeter? Because they're a bit dodgy. I say, I checked the voltmeter. Good. And they say, did you recalibrate it? Because they go out of calibration at the end of the range. And I'm like, of course do you think I'm stupid? Why do you waste my time with these dumb questions? Yes, I checked it. Tick. I say, did you check the magnetic field? And I go, what magnetic field? So sometimes it's my group that asks me dumb questions, and sometimes occasionally, just occasionally, they ask good questions and I'm the one that's being dumb, right? So I go through my group meetings and I answer 20 dumb questions exactly because I'm waiting for that one question where I say, right, this is it. This is now more objective. My biases have been slowly ironed out by engagement with this wider group. Now, come back to Abzal's question. if I engage 10 people in my research group, they're going to look at different biases than if I engage 10 people in the cafeteria, or if I engage 10 students, or if I engage 10 people on an internet chat room. Because the kind of people that hang out in an internet chat room are different from the kind of people that hang out in a university canteen. And they're different from the kind of people that hang out in my group. Now, people in a university canteen don't have some of the biases that my group does. Like, my group all think the same way. So these guys are going to spot certain biases that these guys all share in common and wouldn't notice. But on the other hand, these guys can ask proper sensible questions like, how about the magnetic field? Whereas these 10 guys might not ask such pertinent questions, but maybe they'll take something from left field. So these 10 guys can make my argument more objective. And these 10 guys can make my argument more objective, but they ask different questions and make it more objective in different ways. And I could ask 100 guys in an internet chat room and I might not get anywhere. So it's not just proportional to the number of people you checked with. So you can have many people and a few people, and this one's more objective than this one. And you're going to have some people and some people, and these are differently objective and incommensurately differently objective. Okay, next thing I do is I have to convince a conference. So what I do is I take all my results and I go to a conference and I present it. And then people come up with lots of questions. They say, have you thought about this? Have you thought about that? And half of it's really annoying. And I'm like, why are you wasting my time? And some of it is really good and it helps me look at it from a perspective I hadn't thought of. And as long as my biases aren't identical to my group's biases, which aren't identical to the conference's biases, altogether, if we can forge agreement, if we can come to a conclusion together and say, okay, we've now come to this bigger agreement, then all of our individual idiosyncrasies have somehow been ironed out. Now, it might, of course, be that we've ironed in some collective idiosyncrasies. But at least our individual idiosyncrasies, we find out. Okay? And then I have to convince the referees. So I publish it in a journal. And this is painful. I mean, this is, like, David knows this, right? The students here have not had this pain, right? But referees are idiots, broadly speaking. I mean, right? Why do we go through this pain? If I could just put my papers online on my website, I could get them out there straight away, not spend 2 months going back and forth with a referee who asks stupid questions. Why do I do it? I do it because sometimes they come up with good questions, important questions that enrich it. And on the times when they don't come up with good questions, I still go through the process because I don't know that they're not going to come up with good questions until I've given them the opportunity to come up with questions. And after months of back and forth, and I say, well, that was a waste of time, it's too late because I've wasted my time already, right? If I could know in advance that the questions were going to be stupid, then I could save my effort. But I don't know in advance. I have to go through this process of having these arguments, of forging this agreement, or occasionally ignoring people who disagree because, well, they clearly don't understand what I'm talking about. But the bigger this group I can forge agreement with, the more objective things become. So now we see where climate skeptics come in. Because if I can forge agreement among the scientific community, well, that's great. But if I can forge agreement that includes the general public, the wider general public, then now I can say this is really moving on to something which is objective, strongly objective. And if I can forge it with people who generally agree with scientists anyway, well, that's nice. But if I can find a way to agree with someone who strongly disagrees with scientists most of the time, well, that's really significant. And then I can say something important has happened here. So to engage with climate skeptics is part of the process of making our science objective. And when we talk to climate skeptics, this is not me talking down to climate skeptics. This is not me deigning, as a clever scientist that knows the correct answer, deigning to sprinkle my wisdom on the general ignorant masses. No, this is me talking to them because they can help me hone my ideas. In the same way as I talk to my colleague annoys me and he asks questions, half of which I think are dumb, but by talking to him, I hone my ideas and they become more objective. In the same way as when I talk to climate skeptics, I may think that half their arguments are silly and I may find it annoying, but in talking to them, I hone my arguments and make them more objective. So if we want our science to be as objective as possible, we should go through this whole process, including talking to climate skeptics and convincing them of what we're doing. Now, here's the problem. We don't do that. I mean, I don't spend my life on internet chat rooms arguing with trolls because, well, why don't I do that, right? If I could make my science as objective as possible by spending time arguing with internet trolls, why don't I do that? And those of you who have seen the sort of pragmatism theme coming through a lot of what we've been talking about, this question, why don't we do it, is very similar to the question, is there anything that's more important to science than objectivity? And of course, the answer is yes. Does it achieve the thing I want to achieve? Does it give me a handle on the question I want? And if I can get a handle on the things that I want to get a handle on without it being absolutely objective, then I'll do that. And if there are better ways to get a handle on what I want to get a handle on than pursuing objectivity at all costs, then I'll do that. So every hour I spend arguing with a colleague is an hour that I'm not trying to get more results. And I say, how is my time better spent? Arguing with a colleague to hone my objectivity or going in the lab to get some more results? And most of the time I say, actually, this is an hour well spent. On the other hand, every hour that I spend in a chat room arguing with internet trolls is an hour that I'm not in the lab getting more results. And I say, it's possible that arguing with these trolls, I will learn something really, really important, and this will blow the doors wide open on the climate change thing, and I will learn something new and I will do better science. It's possible. But I won't know that without spending an hour in a chat room arguing with them. So I have to look at it in advance and I say, the next hour I could spend in a chat room or I could spend it in the lab. Which do I expect is going to be more productive? Churning out more data or arguing with internet trolls? And I have to make a judgment. And because I can only do one or the other, once I've talked to them, that hour is gone, I'm never going to get that hour back. I have to make a judgment, and I can never know whether it was how it would have gone the other way. And different scientists draw the line in different places. Some say, I'm just never going to talk to colleagues and publish in journals because the journal editors are all morons. I'm just going to churn out more and more and more data and I don't care what other people think. And some of those scientists do amazing work and they change the world. And many of them are complete Fruit Loops who do terrible science and just write crackpot rubbish. On the other hand, there are some scientists who say, I am going to argue with, or I'm going to talk to, engage with, discuss, argue with everyone, with politicians, with farmers, with teachers, with children, with internet trolls. And some of them find out wonderful stuff and change science. And many of them end up as popularizers who never actually get back into the lab to do new research. So here we have objectivity within science. We choose, one of the reasons why scientists do not go out of their way to, why is that? Sorry, my screen sharing has ended. Okay, there is, once again, Steve now has a record of how incompetent I am with screen sharing. Okay, I'm going to finish off. There's one more slide that didn't hook up to. Wrong thing. Okay, so now what we do is we say, well, where do I draw this line? Different people draw it in different places, and we can never know whether we drew it in the place where we could have drawn it somewhere else, or whether it's a good thing, how it would have gone if we'd have done it differently. And also where we choose to draw the line might change depending on the topic. We don't have conferences trying to explain to the general public different notions of interpretations of quantum mechanics. We don't have big public outreaches to explain the Copenhagen interpretation of quantum mechanics because it's not that important. We don't care if people have stupid ideas like many worlds hypothesis, right? But we do care if people have stupid ideas like I can leave my air conditioning on all the time, even when I'm not in the room at 17 degrees. That does matter. And this is why we do have big public outreach things to try and explain the science to people. And so it changes depending on topic, it changes depending on the individual scientist, and it also changes depending on the time. 50 years ago, we may have said, well, it's good to explain climate change to people, but it's not a pressing issue. Now we say it's really good to explain climate change to people, and it's a very pressing issue. And in 15 years' time, we may well say, we need to sit every 6-year-old kid down in school and explain nothing to them until they've got climate change, because this is the existential issue of our time. And for people who think maybe I'm being a bit extreme on this, if you look at, for example, explaining virology to people, is it important to wash your hands? 18 months ago, it wasn't, it was good that people know the science of why washing your hands is important, but it wasn't an existential threat to civilization. And people said, I could explain this to people, or I could just go into the lab and do more research. And now you have people saying, none of my research counts for anything until I've explained to every single kindergartner why they have to wash their hands. So where we draw the line on how objective we want these ideas changes depending on the person, changes depending on the subject, and changes depending on the context in which that subject fits. So with that note, I'm going to